Let's look at a real-world example. Your friend has a pizza with a 5-inch radius. The radius of your pizza is 2 extra inches. What is the difference between the circumferences of the two pizzas? So your friend's pizza, 5-inch radius, is probably this one because it's smaller. And the radius of your pizza is 2 extra inches. It is the bigger one because remember, the bigger the radius, the bigger the circumference, bigger the circle, bigger the pizza. So now we want to know the difference between the circumferences of the two pizzas. Well, whose pizza is bigger? Your pizza. And let's say we want to represent the circumference as C2, right? Because we're going to be dealing with two different circumferences, so we don't want to confuse them. C2 minus C1, where C1 is your friend's pizza. Where's the C? Where C1 is the circumference of your friend's pizza. Okay, because we want to know the difference. That's why we're subtracting. So how can we represent C2? Well, remember the circumference is just 2 pi r or pi d. So what is the circumference of your pizza? It is 2 pi times r, which is 7 inches, minus circumference of your friend's pizza, 2 pi times 5. And then we can simplify. This is 14 pi minus 10 pi. I just want to leave the pi, so we leave it as nice whole numbers instead of decimals. So then we should get 4 pi inches. Wait. Yes, inches. Did I say centimeters earlier? I meant inches, sorry. So yeah, the answer is that the difference between the circumferences is 4 pi inches, where 4 pi is just a number, because remember pi is just 3.14, so a little over than 12 inches. Let's look at these two examples. I'm going to zoom in so you don't get distracted by the other one. This is asking, what is the measure of arc ACB? So ACB is this arc. So this is the major arc. And we want to know the measure. Sorry, I should be more specific. What is the arc length? What is the arc length? Because remember, it can be in either degrees or units of length. How can we go about this? Well, we're already given the measure of the minor arc, because the minor arc is the same as the central angle, which is 120 degrees. So our major arc, ACB, remember, is 360, because there's 360 degrees in an entire circle, minus 120. So that should give us 240. So that's the measure of our major arc. But that's not the arc length, right? Because the arc length should be in units of length. Whether that's inches, centimeters, meters, yards, stuff like that. So remember, the arc is a fraction of the circumference, right? So what is the circumference? The circumference, we're given the diameter, which is 10. Remember, it's 2 pi r or pi d. So our circumference in this case is 10 pi. 10 pi centimeters. Sorry, centimeters. Where 10 pi is just a number because pi is just 3.14, so a little over 30. Okay, so now what is the arc length of ACB? Remember, arc length would just be the fraction that the major arc makes. Okay, what part of the circumference is the major arc a part of? Well, we know it's 240 degrees, and there's 360 total, and that should give us a fraction of 2/3, and then we times that fraction, we multiply that fraction by the circumference, which is 10 pi. So if we were to, that would be 20 over 3 pi centimeters. And if you plug this into your calculator, you should get 20.94 centimeters. But I'm going to leave it as that so it looks somewhat clean. So this would be your answer. That is the measure, or the arc length of ACB. Now let's look at this example. Maybe I should erase this so you don't get distracted. Okay. Arc AB equals to 12 centimeters. So let's write that in. 12 centimeters. What's the circumference of circle D? Oh, I should have labeled this. Circle D. So sorry for all the mistakes. What is the circumference of circle D? So now they're asking for the circumference. They're giving us the arc length. So we're going to go backwards, sort of, right? So remember, arc length equals. Now I know I keep saying it's the fraction, but remember, we just keep taking the angle of the arc, the degree of the arc, divided by 360 times the circumference. Okay, so we already know that, actually I should rewrite this, sorry, just all over the place. Arc length equals, remember, some fraction where it's how much the arc length measures up to in degrees out of 360, right? Because it'll give us a fraction, times the circumference. Okay, well, we're given the arc length. So we can plug it in. 12 equals, let's just start plugging in what we know, times c. We don't know the circumference, so we'll leave that alone. Now this part, remember, that would just be the measure of the arc in degrees. We can see that it's 40 degrees. 40 degrees. And then we would just solve and simplify. So we can cancel out the zeros. This should give you 1/9 times c equals 12. To solve for circumference, get c by itself. C times both sides by 9. Cancels out. 12 times 9 is 108, so our circumference is 108 centimeters. Okay, now how did we know it was 40? Because we're asking for the arc length of AB. Okay, that's why we used, that's why we used the degree 40, right? Because maybe you're wondering, why didn't we use 360 minus 40? Well, because we're given the arc length of AB. We're not given the arc length of the major arc. So that's why we used 40. That's where the 40 came from. And this 360 is the entire circle. And we divided 40 by 360 because we wanted to know how much of the circumference is made up by the minor arc AB. And because we did that, then we were able to solve for the circumference.